All right, welcome to a little pop quiz on C, one of the most powerful programming languages out there. We're about to run through some of the most common exam traps that can catch anyone off guard. You think you're ready? Let's test the skills. Okay, let's dive right in with our first question. This line of code looks about as simple as it gets, right? But believe me, there is a subtle, critical error hiding in plain sight. This one tiny mistake would cause the entire program to fail to compile. Can you see what it is? And if you said the missing semicolon, you nailed it. In the C language, a semicolon is basically like a period at the end of a sentence. It tells the compiler, hey, this command is finished. Forgetting it is probably the most classic beginner mistake you can make. And that little semicolon problem? It brings us perfectly to our first big topic, C's super strict syntax. Now, it does demand precision, but the good news is, once you learn the rules of the road, you'll start avoiding these common traps without even thinking about it. All right, next question. Oh, professors absolutely love to test this one. It's all about naming rules. Out of these three options, which one can you actually, legally, use as a variable name in C? Take a quick second and make your pick. Now, before I give you the answer, let's actually break down the official rules. In C, we call a variable name an identifier, and it has some very specific rules to follow. The big ones are, it has to start with a letter or an underscore, and you absolutely cannot use a special reserved keyword. So you guessed it, the correct answer is C, number 1. One number is a no-go because it starts with a number, and float, that's a keyword C needs for itself to define data types, so you can't use it. But number 1 follows all the rules perfectly. Okay, so we know how to name our variables, but what kind of stuff can they actually hold? Well, that leads us right into our next section, data types. You'll run into this a lot. Float versus double. They both store a decimal number, so what's the big deal? Well, the key is precision. The easiest way to think about it is that a float is like a standard definition picture, while a double is like the high-res 4K version. It gives you way more detail, but it does take up more memory. All right, we've got our data stored. Awesome. But how do we actually talk to the user? That's where two superstar functions, printf and scanf, come into play. They let us show information on the screen and, just as important, get input back. And here is another classic exam trap. This code looks totally fine, right? It's supposed to grab a number from the user, but there's a hidden mistake in here that's going to make it fail every single time. See if you can spot it. The problem? It's that tiny little missing ampersand. This is an incredibly common mistake people make with scanf. The correct code needs that ampersand right before the variable name, like this, scanf%d and number. So why is this one little symbol so incredibly important? Think of it this way. The ampersand is the address operator. It's like giving scanf the GPS coordinates to the exact spot in the computer's memory where it needs to drop off the user's input. No address, no delivery. Simple as that. All right, let's get into a topic that catches almost everyone off guard. I'm talking beginners, intermediates, you name it. We're talking about type conversion. This is all about what happens when C has to do math with different kinds of data. This right here, this is the ultimate gotcha question. Seriously, we're dividing 5 by 2, and we're storing it in a float, which can handle decimals. The answer has to be 2.5, right? Right? Well, let's see what C thinks. And the output is 2.0000. What? Where did our 0.5 go? Well, here's the trap. Because you divided an integer by another integer, C performs what's called integer division. It does the math and just throws away the decimal part before it even thinks about storing it in your float variable. So how do we fix this? We use a neat little trick called explicit casting. See that float we added? By putting that right before one of the variables, we're basically telling C, hey, just for a second, pretend this integer is a decimal number. That forces it to do a proper floating point calculation, and boom, you get your 2.5. Whew, okay. We have been through some tough quiz questions, from missing punctuation to sneaky math problems. So let's wrap this all up into a final checklist you can use right before an exam. Okay, here are the non-negotiables, the absolute must-knows. If you can burn these 5 rules into your brain, you're going to avoid the most common point-losing mistakes in C programming. Seriously, master these and you'll be writing clean, correct code in no time. And that brings us to our final thought.
We spent all this time on syntax errors, the kinds of mistakes that the compiler will find for you. But the real next level, that's tackling logic errors, when your code runs perfectly fine, but just gives you the completely wrong answer. And figuring those out, well, that's where the real art of programming truly begins.